In this video, we are going to continue naming the structures of alkanes. Now we're going to proceed to name alkanes with different substituents. When it comes to alkanes with different substituents, you can see on the left side of the slide what are the rules. First, we're going to find the longest carbon chain and we're going to assign its alkane name. Then we're going to number the carbon atoms starting from the end that is nearest to a substituent. And then we're going to give the location and the name for each of the substituents, but specifically in alphabetical order. That's going to be the prefix to the name of the main chain. And remember that whenever we have locations, meaning numbers, and we have the name of the substituents, we need to separate them by a hyphen. As an example, let's just take the following condensed structure. Let's take a moment and determine what is the longest carbon chain present in this molecule. The longest carbon chain in this molecule is 1, 2, 3, 4, 5, 6 carbons, or 1, 2, 3, 4, 5, 6 carbons. It doesn't matter which one you select. Both of them are going to be 6 carbons in length. Please do not assume that your longest continuous chain of carbon atoms is always left or right. It's going to be in any direction. It is your main job to actually look at all the possibilities and find what is the correct longest carbon chain. So let's number it. This is carbon 1, 2, 3, 4, 5, 6. I'm going to highlight those carbons. Anything outside of that main chain is called a substituent. So when I go and name my substituents on carbon number 2, I have a fluorine, so that is called a fluoro group. On carbon number 3, I have a CH2 followed by a CH3, that is called an ethyl group. On carbon number 5, I have a CH3. That means that is a methyl group. Like in the rules that were stated, now I'm going to proceed to write these in alphabetical order. So when I build the name for this organic structure, I have to do 3-ethyl, next 2-fluoro, because in between every number and word, we need to put a hyphen. And lastly, 5-methyl. And next, I'm going to write the main chain, which since it's 6 carbons, this is a hexane. Let's explore the next example. Take a moment and find the longest continuous chain of carbon atoms. The longest carbon chain is 1, 2, 3, 4, 5, 6 carbons. So that means that my main chain is going to be a hexane. On carbon number 2, I have a fluoro group. On carbon number 3, I have a bromo group. On carbon number 5, I have another fluoro group. So when I put them in alphabetical order, I'm going to say 3-bromo. And because at position 2 and 5, I have the same substituent, I'm going to say, well, at position 2 and position 5, I have 2, meaning I put the prefix di, and then I put the word fluoro as a descriptor of the substituent, and then I put the main chain. So the correct name for this molecule is 3-bromo 2,5-difluorohexane. In the slides, I have the following problems. I want you to take a moment and name this one. The first thing that you need to identify is the longest continuous chain of carbon atoms. For this molecule, you have 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row. The reason why I selected that as my longest carbon chain, not only because it is, but if you would have gone straight, then this is carbon 5, this is 6, this is 7. That is not the longest continuous chain of carbons in this molecule. Let me proceed to highlight it. So this is my parent chain. Let's now identify the substituents. At carbon number 2, I have a methyl. At carbon number 4, I have a fluoro group. At carbon number 5, I have an ethyl group. I need to put them in alphabetical order. So I proceed to write the name of the structure as 5-ethyl, 4-fluoro, 2-methyl. Octane. Make sure that you also practice from the worksheet how to go from name to condense and skeletal formula. Alkane structures can also be cyclic. Those are known as cycloalkanes. Cycloalkanes have 2 fewer hydrogen atoms than the open chain form that we have explored so far. That means that cycloalkanes have the general chemical formula CnH2n. The smallest cyclic alkane has 3 carbon atoms, meaning that N equals 3. So the chemical formula for that smaller cyclic alkane, which the smallest is 3, is going to be C3H6. And you can see it illustrated in the condensed structural formula that we have here. We have 1, 2, 3 carbons, 2, 4, 6 hydrogens. That's where that C3H6 comes from. Now, we see illustrated 3 carbons in a cyclic system, 4 carbons in a cyclic system, 5 carbons in a cyclic system, 6 carbon in a cyclic system. These have a specific way that they're named. Since they are cyclic alkanes or cyclic alkanes, we have to put the prefix cyclo to signify that they are cyclic. So since this structure has 3 carbons, this is cyclopropane. The next one, 4 carbons, cyclobutane. Next one, cyclopentane. And the last one in this figure, this is cyclohexane. When we are drawing the condensed and or the skeletal structure for these, please notice that they have geometric figures. So cyclopropane is a triangle, cyclobutane is expressed as a square, cyclopentane is a pentagon, cyclohexane is a hexagon. You can also have cyclic system that have 7 carbons, 8 carbons, 9 carbons, and 10 carbons. Simply, if you're given those structures, count the carbon atoms given by the geometrical figure. Let's now learn how to name cyclic alkanes with one substituent. When it comes to naming cyclic alkanes with one substituent, understand that we are just going to write the name of the substituent and the name of the cyclic alkane. Because since we have only one substituent, then we don't have to put a number. Because regardless where they're sitting in the cyclic system, they're going to be on the first carbon, okay? Because, for example, in the one that we have here, if I start at this carbon in my cyclic system, because it is where the substituent, this is going to be carbon 1. And the important thing is that I identified that there are 1, 2, 3, 4, 5 carbons in my structure. So the name of this molecule is going to be bromo cyclopentane. Let's do some practice problems. Take a moment and name this cyclic alkane. The name of this molecule is methyl cyclopropane. Because there's 1, 2, 3 carbon atoms. Let's do one more. Take a moment and determine the name of this structure. The number of carbons in this geometric structure is 1, 2, 3, 4, 5, 6, 7. Specifically, that branch has 1, 2, 3 carbons. So the name of this structure is propyl cyclo, and since there's 7 carbons, heptane. Make sure that you also know how, if you're given the name, how to draw the structure for a cyclic alkane with one substituent.